I am Alberto Macario.
And I am Chiara Relandini.
Chiara and I are students enrolled in the second year of computer engineering at Politecnico di Torino.
We took part on a project in the computer architecture course, held by professors Paolo Montuschi and Luca Sterpone, which consists in programming an FPGA, in this case, the Xilinx Nexus 4 board.
Both of us are interested in robotics and exploited this opportunity for making some personal experience on hardware in a field related to automation.
In fact, we have developed an automated car, which we are going to present in detail. The Batcar. The Batcar is an automated car whose main characteristic is to avoid obstacles, thanks to ultrasonic sensors detection. Its final purpose is to discover what we call safe place, a box in a room which the Batcar is able to identify as its destination place.
The main core of the Batcar is its intelligence. Each sensor produces a 1-bit output signal indicating whether or not the obstacle is closer than 15 centimeters. Then, a 5-bit data bus collects signals by the 5 sensor, which is then processed by the main core. Each sensor receives a trigger signal from the FPGA of 10 microseconds. Then, it sends back an echo signal which is proportional in time to the detected obstacle. In this way, the intelligence activates the motor driver to perform the corresponding movement by means of a 3-bit encoded signal. The motor driver is an H-bridge able to control one servo motor and one DC motor at the same time, thus deciding direction and turns. Finally, it displays the distance covered on the 7-digit display. The 7-digit display module receives a 6-bit signal indicating the distance covered, which is computed by assuming a constant speed and measuring the time of movement. We've implemented a register to store decimal numbers decoded in a 64-bit hexadecimal signal. It is later divided into 8 signals of 8 bits, where each signal corresponds to one digit to be displayed. Moreover, for the sake of clarity, LEDs on FPGA are illuminated whenever the corresponding sensor detects an obstacle. This is made by forwarding the sensor output bus to LEDs.
And now, a brief description of the set of movements the Batcar is able to perform. Let's start with the safe place detection. The Batcar is able to recognize it with the sensor placed on the top, and so it stops. Whenever it detects an obstacle on the left, the car turns right. If an obstacle is spotted in front of the car, it puts into reverse. If an obstacle is behind, the car keeps going straight. It turns left if it detects an obstacle on the right. As two obstacles on both sides are present, the car goes straight. An obstacle on the left and one in front of it make the car go back. As 3 obstacles are spotted, one ahead, one on the side and one in the back, the car stops moving. Whenever one obstacle in the front and obstacles on both sides are detected, the car goes back. If obstacles block all directions, the Batcar cannot move. What's more, The car is able to take a decision whenever no obstacles are detected. Indeed, the intelligence enters a loop of 6 possible decisions, executes one of them, and remembers until a new obstacle is found. This video is a short example. Each time one sensor is covered and freed, we can observe the car taking a different choice. The car has been realized by joining parts of an old RC car and by partially 3D printing it. Indeed, wheels and motors have been recycled, whereas we decided to design ourselves the frame of the car, to correctly place FPGA and sensors. But, since the printing area was too small, we had to divide the project into 4 components, which at the end we assembled together thanks to the proper design.